So all of these different valid forms, as I said before, can be used as rules for determining whether or not an argument is valid. So in the very first subsection that I assigned to you to read, the book introduces the first 4 of 8 rules of implication, as they're called. So we've already talked about these rules: modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. Now, why do we care about this? Well, we are going to use these rules in order to show that an argument is indeed valid. So in all of these cases from here on out, every argument is going to be valid. So you're not going to have to worry about figuring out whether or not the argument is invalid, okay? You don't use the proof method, natural deduction, to prove invalidity. You use it to prove validity, okay? So what we're trying to show is that even in very complicated arguments like this one here, we can use these basic rules in order to determine that it actually is valid, to prove that it is. So we're already going with the assumption that it's valid, and what we're doing in all of these exercises and all these cases is we're just showing, we're kind of unpacking, if you will, the steps to show why this is valid. Again, that's always what we're trying to do. Because in every single valid argument, there is a combination of these different forms of valid forms of argumentation, these rules of implication. So let's look at this argument here on the board. Again, this is a valid argument. So what we have here is an argument with 4 premises, as noted here, and then in proof method, we take the conclusion, and on the very last premise line, we put a slash mark, backslash mark, and we put the conclusion. So this is the conclusion. Now, how does proof method work? Well, what we're trying to do is we're trying to derive this conclusion from these premises. So you will know when to stop with the proof method when you finally arrive at, in this case, when you arrive at the conclusion. So we're basically just trying to show the extra hidden steps here for why this argument is valid. Now, as I said earlier, the trick in all of this, and again, it's sometimes can be a little bit hard to do, but you kind of have to get yourself kind of acclimated to doing this, is the ability to see these forms in this argument. Okay, so let's kind of go step by step in how we would prove that this argument is indeed valid and you can indeed derive M from these 4 premises. Okay, again, for the most part, you will use every single premise. So that's one thing to keep in mind. And once you've used, as we'll show here, one premise, you usually are done with it. Usually. Not always, but usually you are. Okay? So let's go ahead and look at these 4 premises. Ignore the conclusion for a while because, again, that's just our end goal here. So do we see any of these rules, modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, do we see any of these in these 4 premises? Well, in fact, if you look here, we have a not in on line 3, and then here on line 1 we have be or horseshoe in. Okay, so what we have here on 3 is the negation of the consequent on 1. Okay, so this is just like the rule of the modus tollens rule, the valid form of modus tollens. So we can say this and say, oh, okay, all right. So here's one of the forms here. So what we will do is we'll add a step, our next step, and we will say, all right, so by lines 1 and 3, if you use the rule modus tollens, MT, you can derive not B, right? So essentially what's going on here is you're kind of off, if you think about this visually, off to the side, you're kind of saying, okay, you're picking those 2 lines out, you're saying, okay, here we are. Oh, okay, well, if you use modus tollens here, you're going to get your not B, right? That's sort of what you're doing mentally, this procedure right here. But you're showing, okay, all right, you can derive not B from lines 1 and 3 using the rule modus tollens. Okay, so for the most part, you're kind of done. There are exceptions to this, but you're pretty much done. And if it helps you, you can maybe just sort of check off that you've used these lines. Now, I'm saying this as a kind of caution here. Sometimes you have to go back to a line you've already used in order to derive something else. Sometimes, okay? So, but if it helps you kind of mentally, visually to get through this, that's fine for right now, okay? So, okay, so what happens is once we start getting these derived lines, we can start using those lines too to derive other things from the original premises. Right? So, okay, we can't really seem to do anything with not I yet. Okay? And that's another thing, too, I need to note. When it comes to rules of implication, you can't just use it on a part of one of the lines. So, for instance, you might look at this and say, oh, look, there's a not I here, and there's I or am here. That's just like disjunctive syllogism, right? So we got a negation in one of the disjuncts. Okay, I can use disjunctive syllogism. You can't. And the reason you can't is you haven't gotten rid of this not be and the horseshoe. You've got to keep isolating, stripping them down, basically, until you get I or am by itself. So again, rules of implication. You cannot use the rules of implication on parts of propositions. Okay, it has to work on the whole line. So, alright, that's out of the question for right now. Now, we have this new line here on line 5 with not be. Okay? Well, this matches with the not be here on line 2. Alright, so what does this look like here? Looks like modus ponens. Same value. Main operator here is the horseshoe. Alright? We knock those out here. If you take by lines 2 and 5 and you use modus ponens on that line, then you can derive I or am. Okay, so there you go. So now you've gotten rid of that not or be or and the horseshoe as well. Okay. So now you've essentially got yourself to the point where you can do what you wanted to do with line 4. Okay, so again, our two remaining lines, 4 and 6, we see here we got a not I, and then I or am. This is just like our disjunctive rule, right? So from that, we can derive am. And again, we do our usual, where we say from lines 4 and 6, using disjunctive syllogism, we can derive am. And there we go. We've reached our conclusion. We can stop with the proof. We've proven it. Another thing to note, I've been just sort of doing this, but I need to mention this explicitly. Whenever you start doing the derivations here, you've got to use your justification. You've got to put down your justification. You've got to say, where are you getting this derivation from? You're getting it from these lines using this rule. You always have to do that. That's the form in which you have to use with these proofs. Okay? All right. So let's try one more here for these rules. So just to mention, as we're going here, I want you to pay special attention to the strategies that each chapter on the rules of implication mentions at the end. Those will basically help you. If you're really having trouble getting started on a proof, those rules are kind of there to help you kind of get through that and sort of say, look for particular cases where this is the case. The number one rule will always be, first find the conclusion in the premises, okay, and see, kind of work backwards, kind of reverse engineer it, and see how you can get that conclusion out of a premise. So let's try another one here. So we'll try this. So first premise is W horseshoe I or not C. Second premise is I or not C, horseshoe not D. Third premise, I, horseshoe, D. Fourth premise, W. Conclusion, not C. Right, so there is our valid argument. And now it's time to prove how we can derive not C from those premises here. So again, if we kind of use that first rule, that first strategy the book mentions, well, it looks like we have our not C here on line 2 and line 3, or excuse me, line 2 and line 1, so perhaps there's something there that will help us along the lines to do this here, right? So perhaps that will come into play here soon, right? That maybe that's the line that we're going to get this from. Okay? So you might be inclined again to sort of use hypothetical syllogism here because again you have identity here on both sides. But let's resist that for a second here because again we're trying to get the not C, we're not trying to eliminate it. So what else can we do here? Well, we have, if you look here, looking for our forms, you can see oftentimes it helps to look at the lines where there's a single letter. What can that single letter do for us? Well, it's up here on line 1, and it's the antecedent of a conditional statement. So automatically we can say, oh, okay, so we can use modus ponens here. So by lines 1 and 4, using modus ponens, right, we can derive I or not C. Okay? So we've kind of used those lines here. All right. The next step, what can we find here with the new line that we've made and lines 2 and 3? Well, we can see here that this line 5, is identical to the antecedent on line 2. So, okay, let's do that. All right. So we'll just eliminate that by lines 2 and 5 using modus ponens. That's modus ponens there. We will derive not D. Okay? All right. So we've used that. All right. Now what do we have left? Well, we have lines 3 and now 6. We can see here that line 6 is the negation of the consequent on line